So today we are super excited to welcome back Elisa Bayraktarov. Apologies for butchering the last name there. I haven't had a lot of practice with it, but I hope to do so in the future through better integration between CBCS and EcoCommons, particularly around Marxan and using your habitat suitability models. So without further ado, I'm going to let Elisa do the rest of her introduction here and get underway. Thanks again for bearing with me.
Hi guys, I just unmuted myself and I will shortly share my presentation slide with you. Hopefully that will work. Hang on, bear with me. Daniel, give me a thumbs up if you can see the presentation. Fantastic. All right, well guys, welcome to my talk. My name is Elisa Bayraktarov. Yeah, I'll be giving the seminar today, but before we begin, I really would like to acknowledge the traditional owners of the land on which the University of Queensland is situated, and those are the Turrbal and the Jagera people, and I acknowledge the elders past, present and emerging of all the lands that we work and live on, and recognize the extraordinary contribution to the cultural, economic and scientific domains that we'll be discussing today. So in this seminar, I'd really love to take you on a journey, actually, to show you how the EcoCommons is being developed to become the platform of choice to analyze and model ecological and environmental challenges. And my job as EcoCommons program manager is to lead the development of EcoCommons and to make sure that the platform is being built collaboratively, is based on the best available science, and is being created as a national research infrastructure which is relevant and needed. And if I look in this direction, guys, that's because I'm looking at Emilia and Rob, who are here with me in the room that I introduced at the morning tea. All right, and glitches. No problem. So some of you might remember me from my time here at CBCS. So I called CBCS home for a long time. And back in the day, I worked with Hugh, with Aisha and Misha, and over 40 other project partners to develop the Australian Threatened Species Index, which is currently available for birds, mammals, and plants. If you have the time, check out the TSX on the tsx.org.au page to find out more. And yeah, the TSX is actually quite cool. It's a biodiversity indicator which allows you to look at threatened species trends almost in real time. So it's really great for reporting and also to make decisions about which groups of species and where are most in need of our help. And back to EcoCommons. So I've started my journey as the EcoCommons program manager in May last year. So I'm presently based at Griffith University. The EcoCommons is a partnership program, though, between 9 different organizations, of which Griffith is one. And we are building a trusted single platform for ecological and environmental modeling and analysis. And our mission is to build the platform of choice for environmental problem solving, pretty much. So the program itself will run for 3 years. We have a budget of about $5 million. So between 2020 and 2023, with the hope of continuation, of course. And we are building EcoCommons to become a national research infrastructure. So our vision is really to empower Australian practitioners and researchers to use this trusted world-leading a platform that is providing ecological and environmental modeling tools to protect the planet. So we are a consortium of all of those organizations. And at EcoCommons, we support environmental problem solving, and we do this by partnering up with research, government, with industry, NGOs. We provide seamless access to biodiversity data and as well as the tools for analysis. And but we also deliver some training to researchers and practitioners. And we built virtual laboratories for this purpose. So now this might actually sound quite familiar for you, to you. So imagine there is a conservation problem that you'd really like to solve, and you need to write data, right? And there is so much data out there, and it exists in many different shapes and formats and in so many different places. Where do you start? So choosing the right data set is so important, and also the right data quality, because, well, the whole solution of your environmental problem depends on data quality and choosing the right data set, pretty much. So suddenly you're presented with this challenge to find this right data that you need and make the best use of it. So as an individual researcher, student, or policy decision maker, how do you get the most out of this very data-rich world that we live in? So, and this is an example that you may face as a researcher student in ecology. So let's say you want to run a species distribution model, right? So what you do is, the first thing you need to get data on all the existing presences and absences of your species of interest. So you can get data like that from the Atlas of Living Australia, or GBIF. And then you have to prepare, you have to data wrangle this data, you have to evaluate this data, and now you have to select the right species distribution modeling algorithm, and there are about 25 currently being used in science. Now you have to evaluate your model and make sure that the data is being visualized properly and accurately, and then you have this distribution of your species. So you have the present day distribution of your species, and you may want to run a secondary analysis where you predict where suitable habitat of that species would be in the future. So you need to access all these other data sets. So lots of data, and whenever new data becomes available, or you wanted to run this whole model for another species, you have to repeat this loop. And let's say you're a quite good coder, it will probably take you a couple of days to actually get this done. Now, and this is where virtual laboratories come in very, very handy, because they are there to make your life easier and to reduce the time that you spend on data wrangling and configuring models, so that you can actually spend much more time on actually solving problems and publishing scientific papers, or finishing your PhD, or making environmental decisions. So the EcoCommons Australia program builds virtual laboratories to bring all this fantastic data that already exists into one place, into one single trusted platform. It connects it with published methods and tools and analytical workflows, and backs this all up by high compute capacity and cloud storage. And by doing this in one connected single platform, running scientific workflows becomes much more transparent, reproducible, and streamlined. And you can also collaborate with others, because you can share all the scripts of your models. So in addition to that, we have great user support. Emilia is here with me. She's our support and training officer at EcoCommons. And we also have a great community engagement with our users. So here I have next to me Rob, who is our change and communications manager. And we also have a good governance model. So EcoCommons is not starting from scratch. It's actually building on 6 years of experience of building virtual laboratories. So that was led by the team at Griffith in partnerships with others. And really the history of the virtual laboratories at Griffith started as early as 2011. The first virtual laboratory, the BCCVL, was released in 2014. And since then, the EcoCloud, Tinker, and CSDM, further virtual laboratories were built. And now let's have a chat about who EcoCommons is for. So we're building EcoCommons for you guys. So we're building EcoCommons for researchers, educators, decision makers, and students. So researchers get access to lots of data sets and analytical workflows, but also command line environment where they can run their own scripts on the cloud by using high performance computation. So educators can download ready to use lecture material, and decision makers can use point and click interfaces. So virtual laboratories for quick access to data and access to trusted analytical methods that can be used for reporting, because they can be easily reproduced and repeated and also shared with colleagues. And students can learn more about ecological modeling by accessing our step-by-step guides and online material. So we are planning to launch the fully fledged EcoCommons platform in 2022, hopefully at the ESA conference, November, December 2022. And for its launch in 2022, we hope that this is what we'll be offering to our users. So access to thousands of data sets all in one place, easy solutions to data wrangling, access to trusted models and algorithms, virtual laboratories that are really nice and easy to use and that are very user-friendly, access to free cloud storage and access to high-performance computation. And hopefully the end goal is to give you guys very easy access to, well, high-impact quality results in much shorter time that are repeatable, reproducible, and where you can collaborate with others. So hopefully this is inspiring you a little bit, and it's coming, guys. I'm telling you. So before we started actually to build the EcoCommons platform, we asked ecological modelers about their challenges, needs and wants, desires, frustrations, and all the other things. So we sent actually a survey to all of our users from existing services, so BCCVL and EcoCloud. So basically, we sent out this survey to about 7,000 users, but also through Twitter and through networks. I think I sent it also through the CBCS. So thanks to you guys for participating if you did. So that was a survey. We got about 400 respondents back. Most of them are existing users, but there are also some new potential users. Most of them are from New South Wales, Queensland, and WA, but there were also a couple of respondents actually from overseas, which was interesting. So, majority of users currently are undergrads and doctoral students, but we also have some use cases from government and only a little bit from private industry. And most people are using those tools for ecology conservation and biodiversity. So, and these are some of the challenges and hopes that our users express. So postdocs, for instance, want more open source resources. Undergraduates want more help pages that help them understand models and choose the right model for their questions and their assignments. People from the private sector want a better way to collaborate with each other, and they want access to and possibility to share sensitive information and data. So that's threatened species locations and stuff like that. Government workers want to have more confidence in the models and the model outputs, and they want support for their decision making. And senior researchers want scalable virtual laboratories that really get improved continuously as technology gets better. And summarizing the needs, well, our users want models like species distribution models and climate change projections, and they're very much interested in the ethical use of sensitive information for their analysis. And they want a better guidance which model to choose and when, they want easier access to good quality data, which is clean from biased records, so that they spend less time on actually data wrangling. They want more compute power, a better way to collaborate and carry out research in a repeatable and transparent manner. And people were particularly interested in ethically sharing data that I think I mentioned that before. But we also learned that our communication channels presently don't really reach the private industry and also the NGO sector. So we didn't have many respondents from those areas. So we probably need to apply a more targeted approach. The barriers that people found were around available training on models. So people were struggling with that, and also with the level of coding required. So people wanted to get better at digital literacy, and they really hate data wrangling. So as probably no news. So everyone wants better compute power, access to secure platform that allows them to collaborate with each other. And we do see some opportunities here to build in a sensitive data haven for upload and sharing sensitive, say, threatened species locations information that can be analyzed on an EcoCommons platform. So this is one of our deliverables that we'll be moving towards. And we also started thinking about focusing on training and increasing the digital literacy and capacity building of people. So we are also thinking about developing case studies together with government agencies to showcase how EcoCommons can be used. And learnings from that is, well, there seems to be an appetite for the existing EcoCommons services like BCCVL and EcoCloud amongst our user communities, and our developments, our new developments are focused on the right things, as it seems. Right. So we listened to you guys and we delivered our first training to increase digital literacy. So only a couple of weeks ago, we ran our first training module on R for ecologists, like basic R for ecologists, which is great. It was an online training. We joined forces with QCIF, the Queensland Cyber Infrastructure Foundation, and the Atlas of Living Australia. And this is a picture of all training facilitators of this 2 half-day R workshop that will sure repeat very, very shortly, because we got lots of interest in this module. So a little bit about our existing services. Our primary virtual laboratory is the Biodiversity and Climate Change Virtual Laboratory, or BCCVL. The BCCVL is a point-and-click modeling portal where you can run trusted species distribution models and also future climate change projections. And we provide our users with quite a bit of pre-processed, so already data wrangled data, pre-processed and curated data sets that is ready to be used in the models and in a friendly modeling environment, actually. And the BCCVL really encourages a high standard of species distribution modeling, while it's really removing those technical barriers while increasing scientific rigor, so to say. And this approach allows researchers, decision makers, and students to focus really on conducting meaningful science and producing high impact results rather than on a technical side of things. An example of the data sets that we are bringing together are data contained within our collaborator, the Atlas of Living Australia, and the data that is accessible through their species portal. So increasingly, we're using the infrastructure of the BCCVL to develop new platforms that can plug and play into already existing national research infrastructure. So in the BCCVL, you can basically get access to Atlas of Living Australia data, bring it into EcoCommons and analyze it there. And this is a video. It's a 12-minute video, but I'll only play the first 2 minutes of this video. I'll share the link to this presentation slides in the Zoom chat after the presentation, so you can watch it at your leisure. But let me give you a bit of a feel what the BCCVL is.
Welcome to the BCCVL. I'm going to briefly demonstrate some of the really great, easy-to-use functionality that enables users to conduct species distribution and climate change models in a point-and-click interface without any coding. So let's first take a look at our data sets. The BCCVL provides access to thousands of data sets for climate, environment, and biological data. Users can visualize and query each of these data sets within the BCCVL, where you can toggle between each layer to make sure it's the right fit for your modeling experiment. You can zoom in on specific areas to inspect the data. Users can also import species occurrence records directly from other platforms. This includes the Atlas of Living Australia, or ALA, and the Global Biodiversity Information Facility, or GBIF. So here we're searching for a mountain ash species, which we're going to use for our demonstration today. Users can also access species trait data, which comes from ACOS. Users can also upload their own data to use in modelling experiments. All you need to do is select which data type you're uploading, fill in some information about your data, and upload it. Let's take a look at our experiments, where we have access to 7 modelling experiment types. 4 of these are primary, and the other 3 are secondary experiments. Welcome to the BCCVL. I'm going to briefly
I never get this right. Okay, so hopefully you got a little bit of a feel what the BCCVL is. This is just a little, well, we are the CBCS here, so I'll bring you a bit of a conservation example, what you can do with the BCCVL super quickly. So look at this lead-beater's possum. It's very cute, but it's also critically endangered. And this little critter requires the mountain ash as its habitat. So what you can do quite easily through accessing data from ALA and running virtual laboratories from the BCCVL, like the BCCVL, is you can create a map of the current distribution of this little critter and also project into the future under business as usual. And you can also look at maps that are showing the changes, like either contraction, expansion, or no change at all. And you can do this with the habitat that this critter needs, which is the mountain ash. So this is the current distribution. This is the future distribution under no climate change, under no climate action on climate change. And then there is the range change map. So you can tell that especially these maps here can really inform management actions about what we can do to prevent this little guy from becoming extinct. All right, so the EcoCloud. One of our outer great platforms is the so-called EcoCloud, and EcoCloud is an online coding environment designed for ecologists that run code and want to run code on the cloud without using your local resources or your computer. So imagine you want to run your 4 weeks of analysis, you can run it on the cloud and still send emails. Wouldn't that be great? And the EcoCloud really requires a minimum setup that enables you to write, edit, and run R, Python, or terminal code, and it's quite easy to use. So I'll show you only the first minute and a half of this little video illustrating EcoCloud.
Welcome to the EcoCloud. The EcoCloud is a cloud-based computing service specifically tailored to ecological researchers and their data. It brings together storage, high computing servers, coding environments, and training all within the cloud. Once you've registered and logged in, you're ready to start coding. Once you launch your notebook server, you can choose between R or Python servers to use to run your code. For this example, I'm going to launch an R server. Once you've launched your server, you can see lots of great tools that you can use. For example, you can link your code to your Google Drive, so you can store all of your data here. You can also access pre-written Jupyter notebooks, which have training code so you can brush up on your coding skills. You also have the option of which environment you would like to use to code in. For this example, I'm going to use an RStudio workspace as it's one of our most popular tools. You can run all of your code as you normally would on your local computer.
Okay, and that's it for now. So our users of the existing services of EcoCommons, BCCVL and EcoCloud. So we have about 6,000 users from BCCVL and about 1,000 of EcoCloud. Users are growing. Most of them come from universities, so they have this edu.au email addresses. Okay, let's chat about the future of EcoCommons. And I only have a couple of slides, guys, so don't worry. So we're thinking of EcoCommons as a pipeline from model development to sound decision support. And the program builds virtual laboratories for 3 different sort of streams of usage. So for instance, virtual laboratories like the EcoCloud is a place where models can be developed and tested. So therefore, people who bring their own scripts and run their own analysis and want to run those analyses on the cloud and want to use a command line environment and want to access high performance computation, and really for users who already know how to use basically parallel computing to harness the power of the cloud. So this is also the place where we are developing new models and test them. And then for the more sort of broader range of users, we have virtual laboratories like the BCCVL that are providing point-and-click interfaces that enable you to access trusted models and data platforms. So you get access to trusted models, but also highly curated data, and you get a really nice user interface that you can manipulate quite easily. And finally, the last stream here of work is creating custom-made portals. So that's for specialized users, like those, for instance, from governments. And we are very much interested to produce virtual laboratories that are policy-driven and make the life of decision makers easier by providing them with outputs for decision support. So those virtual laboratories are basically carved from trusted models and data platforms, but they are customized to the needs of our users. So we have them now expert panels. And they also have a point-and-click interface, which is really easy to use and access to highly curated data sets. And people can also upload their own data if they want. And they have a feature where people can share and publish models and also share those with each other. And examples here are the so-called collaborative species distribution modeling portal, which was developed for Queensland, New South Wales and Commonwealth governments so that they could run their threatened species SDMs and share them with each other. And we are just about to start a collaboration with a new project, which is developing a portal for users from biosecurity called the Biosecurity Commons. So that's a project led by the University of Melbourne and Griffith. And so what is happening when? So this is our timeline when the platform is going to be available. So we already started, we started by developing a plan for the build of the platform under consultation with national and international stakeholders. And in April, we built the components of the platform or the platform foundation in their most basic state and made sure that they are all talking with each other. So now we're adding functionality to those components, and we're preparing for opening the platform for user testing by the end of September. So by the end of September, the platform will contain the functionality of the BCCVL and the EcoCloud, but they'll be performing much more seamlessly, faster, and without glitches and without crashing. And the cool news here is that you can be part of this. So we are always on the lookout for people who want to test our platform and break it and let us know how they did it so that we can improve it. So I'll also show you the QR code at the end of this presentation, so don't worry if you don't catch it now. But prepare your phone because it's coming. Then in May next year, we'll be releasing new functionality that we'll be working on with our partners. And then the final tested, ready to go platform is planned for November 2022. So this is when the EcoCommons platform will be fully fledged, will contain all the scientific workflows and will be released and launched at a big event. Right, so I'm talking about old and new workflows. So the old workflows are from the re-engineered BCCVL and EcoCloud. So those are going to be released in September 2021, so it's coming. So SDMs, multi-species SDMs, trait modeling, climate change projections, ensemble modeling as well. This is when you actually run multiple models and you take the average output to reduce noise. And also command line environment, so that's the EcoCloud. And the new workflows that will be released in May 2022 for user testing will be data cube analyzing tools, a spatial analysis tool, which is creating diversity indices called Biodiverse, community modeling, biosecurity mapping, and we'll also integrate the outputs from the so-called habitat condition assessment system model into EcoCommons so that people can look at habitat conditions scores as compared to reference sites for Australia. Righty, so we are planning to integrate the current services, so BCCVL and EcoCloud, and then we'll be developing, by September, the EcoCommons platform will basically have these 4 components. So the analysis playground will be the command environment, so basically the re-engineered EcoCloud. And then the functions toolbox will be a place where people can access analytics and basically build their scientific workflows. The Data Explorer will be a place, basically like a Google search, but for data sets, where you can find the data that you need for your analysis, but you'll be also able to upload your own data. And the Results Manager will be a place where you can compare any output that you create anywhere on EcoCommons with each other, and also add additional layers of information on top of it and visualize it. So we want to integrate with others. It's really important for our investor that the platform and its components are reusable and can be adopted by others. So we are developing a guideline on how others can actually integrate with EcoCommons, and we call this the integration blueprint. And I'm just checking the time. And there, for the integration blueprint, as we currently see it, we see 3 ways of integrating with EcoCommons. So the first way is to create a machine-to-machine connection, which enables certain components of the EcoCommons platform to talk to the backends of the EcoCommons backend and the external collaborators backend. So that's one way. Then another way is people can build on top of the EcoCommons platform and by developing custom extensions to the platform, and then they can be rebranded as the collaborator wishes. We don't mind how people want to brand stuff. We are happy to do things together with people. And the third one is, okay, you take the entire platform and you deploy it somewhere else, and but then you have to self-host it, which is quite a bit of work, because you don't have Emilia and you have to offer support and training. All right, so that's that. And ideas for future collaborations, especially here at the CBCS. So this is probably interesting to you guys. So a couple of things that we came to discuss today, and we already had a really great conversation with Ruben in the morning about Marxan integration. How do we get outputs from EcoCommons to be inputs for Marxan? Well, guys, you know that Marxan is quite data hungry, and it requires information like species distribution from species distribution models. Marxan with probabilities can also access probabilities of suitable habitat. And those are the 2, well, I guess most popular workflows that Marxan has, the standard workflow and the Marxan Connect workflow. And we believe that EcoCommons can produce outputs that can be used as inputs here in both of those workflows, like species data, habitat data, landscape data. We'll be very keen to talk to you guys about how can we integrate both Marxan and EcoCommons. Another idea is the Threatened Species Index. So the Threatened Species Index that is producing trends on Australia's threatened species uses this workflow where data is being collected by people on the ground, lots of data providers, custodians, or researchers, people from governments, people from agencies, citizen scientists, lots of people collecting data in a standardized, systematic way, repeatedly at fixed sites. And then this data is being uploaded into a confidential database. So the data sharing agreements are signed and everything, and data is being processed, aggregated temporarily, put into an aggregated database where all the sensitivity has been taken out. So all the sensitive species locations have been de-identified, and then trends are being run with the Living Planet Index, and then those trends are being populated in the web app that you can interrogate. Now, I think we could start thinking about if we created a machine-to-machine connection to this step here where the data is being processed, we could, without giving out any information on sensitivities around species, we could use this data to produce species distribution maps and suitable habitat calculations for the same data that we use to produce trends. So we would have a set of trends, and this is the species distribution map, which could be an application that I'll be very, very keen to start talking to you guys about. And this is a call for action. We are going to have some drinks today at 4:30 at St. Lucy's, so please join us. So that's one call for action. Another call for action is don't be a stranger. become an EcoCommons pioneer, be the first to explore and test our new tools. Don't forget, we'll be releasing the platform for user testing end of September. So sign up for the user testing, sign up for this newsletter. Visit our webpage. We're currently redoing our webpage, so it will become much better. And also follow us on Twitter. So on Twitter, we are usually sharing training happening, like training modules being advertised. So that's pretty much me. And we have some time for questions. Thanks, guys.